To graph a line, we need 2 points, at least 2 points. So here I will create a table and I will graph those 3 lines using a table. On the first one, y equal negative 2/3 x, all I need is 2 points, so I can let x equal 0. And when we sub in 0 in place of x, we get negative 2/3 times 0, which is 0. And then you can choose any other point you want to. For example, I could use point 1, and when I sub it in, I get negative 2/3 times 1, which is negative 2/3. And as you see, negative 2/3 will be difficult to graph in my graphing paper here, because that's the decimal number. So I will avoid using this point, and I will go to a more convenient point. The next point I'm thinking of is 3. Here is why. Negative 2/3 times 3, the 3's cancel out, and we get exactly negative 2. So that is an easier point to graph. So going back into my picture now, I have the point 0, 0. That will be right there in the origin. And then I have the point 3, negative 2. So go 3 on the x-axis, and then negative 2 on the y-axis. So it should be somewhere over here. Okay, and those are the 2 points, and then just connect the 2 points to get a straight line. Now, if you want to make sure you have the right line, you can do extra points and see if the extra point falls on the same line. For example, the next convenient point for me will be 6, because I will say negative 2/3 times 6, and you see, so I'm taking multiples of 3. 3 is in the denominator. And you see how 3 goes into itself once, into 6 goes twice. Negative 2 times 2 gives me negative 4. So again, I got a nice whole number. To plot the point 6, negative 4, I will go 6 on the x-axis, negative 4 on the y-axis. That's this point right here. And so do you see how if I was to extend my line will go through all 3 points. So all I need to graph this line is 2 points. But if you find a 3rd point, you can kind of double check that all the points are aligning on the same straight line. So if there is an error, you can catch an error. Okay? On part B, I will repeat the same idea, x and y. We do not have a denominator here, so it will be easier to just use points in a row. So I will use 0, 1, and 2. Okay? Sub in 0 in place of x, we get 6 times 0 minus 10, which is 0 minus 10, that's negative 10. And then I will use point 1, I get 6 times 1 minus 10. That will be 6 minus 10, which is negative 4. And on the last one, I will use point 2, 6 times 2 minus 10. That will be 12 minus 10, and that will be point 2. So to plot the points, the first one is 0 on the x-axis, negative 10 on the y-axis. So right there barely in my graphing paper. The next point 1, negative 4. So go to x equal 1 and then go down to negative 4. And the last point is again for me to double check that everything aligns. So it will be point 2, 2. 2 on the x-axis, 2 on the y-axis. And connect all I needed to remember was 2 points. The 3rd point is there to double check for me that all 3 points align and they belong on the same line. And that's a straight line I'm trying to graph there. And the last case we have is to make a point here that the first 2 were solved for y, and we constructed the xy table. The last one is not solved for y. Okay? We have the x and the y on the first side, and you can use the formula like that. You don't have to solve for y. So let's go and create the table x, y. And since we don't have any ratios, where it looks like we don't have any ratios, the easiest numbers to use are 0. But again, I'm going to try to avoid getting ratios. So let's see what we get. If I let that will be tricky. So let me show you what I'm thinking. If I let x equal 0, right here I have 4 times 0 plus 3y equals 1, and 4 times 0 is 0, right? So we get 3y equals 1, divide by 3, we get y equals 1/3. And that's exactly what I wanted to avoid. I wanted to avoid a fraction because those will be more difficult to graph. So we may not be able to see in that format what points are more convenient in order to avoid ratios. So let's go ahead and solve this equation for y then. Minus 4x on both sides. 4x's cancel out, we get 3y equal 1 minus 4x, and now divide by 3. We get y equal, and you can leave it like that, or you can break it into two ratios, it doesn't matter. We can break it down, 1/3 minus 4/3 x. Now we want to think a little more and decide what kind of values do we want for x so that my y coordinate will be a whole number. Okay? Anything will work, but I'm just trying to avoid having a fraction because it will be more difficult to graph. So I'm thinking the next number I will use is 1. Subbing 1 in place of x, we get 1/3 minus 4/3 times 1. 1/3 minus 4/3 is negative 3/3, which is negative 1. So that's a good point to graph, 1 comma negative 1. Let's see, if we sub in 2, do you see how we will get 1/3 minus 4/3 times 2? So we get 1/3 minus 8/3, because you multiply across the top. 4 times 2 is 8, 3 times 1 is 3, and 1 minus 8 is negative 7/3. That will not be a nice, a convenient point to graph. So I will not use x equal 2. I'm thinking the next point I'm going to use is x equal 4. So if you don't see that, you're probably going to try x equal 2, x equal 3, and you will see that you get fractional answers. So skip those and then go to x equal 4. So if we sub in 4, we get 1/3 minus 4/3 times 4 in place of x. So we get 1/3 minus, this is 4 over 1, so 4 times 4 is 16, 3 times 1 is 3, 1 minus 16 is negative 15 over 3. Negative 15 over 3 is negative 5. So now we have a nice number to graph. So let's go and plot 1 comma negative 1, 1 on the x-axis, negative 1 on the y-axis, right there. And then 4 on the x-axis, negative 5 on the y. 4 on the x, negative 5 on the y. And those 2 points will be sufficient